Hi all, today we are going to discuss about the Jones chopper. So last class we have seen the voltage commutator chopper. This is just an extension of a voltage commutator chopper. This is widely used for speed control of DC motor. So last class we have seen that basically the voltage commutator chopper is nothing but it employs the class D commutation method for turning of the main thyristor. Same thing is employed here. Here the main difference will be in the case of voltage commutator chopper we have only seen that directly the load is connected and one separate inductor is used in the turn off circuit, that means capacitor and one inductor plus a diode. This combination is used for turning of the main thyristor. But here in this case, instead of simple inductor, we go for an auto transformer. This auto transformer basically have two coil. One coil is L1 which is connected in the turn off circuit. Another one will be inductance that will be having L2 which will carry the current that is passing through your load. So this will help in speeding of the turn off process of the main thyristor. That means it will provide the extra energy to the capacitor so that it can effectively turn off the main thyristor without any failure. So how that will happen, that we are going to discuss in this lecture in detail. So before proceeding, let us take the standard notations what we are going to see in the waveforms. I am assuming the standard notation as I am taking the lower side plate, that means lower plate of the capacitor as my reference for measuring the voltage. That means lower side I am taking as reference, that means plus with respect to the top plate, and the current direction I am taking that the current is going upwards from the capacitor, that I am taking as positive. Similarly, the across the thyristor, main thyristor I am representing by Tm, and the current passing through main thyristor is Im, and voltage across this one I am taking the plus in the left side, minus in the right side. Similar is the case for the auxiliary thyristor. I am naming as a TA, current is IA and voltage is VA, and a diode I am taking this one as a D1, inductors L1 and L2, FD is the freewheeling diode, and the current passing through your load that is I0, that means it is entering this terminal, and reference I am taking the V0 as plus in the top or minus in bottom. And coming to the freewheeling diode, current passing in this direction, that will be my freewheeling diode reference point. So here initially I am assuming that my capacitor is charged with top plate positive with respect to the bottom plate with a value of equal to the supply voltage. So how it will be charged to supply voltage come the second cycle onwards, that I am going to explain you why I have taken this as a reference. So at the time of time t is equal to t0, let us take at this time. So what I am doing, I am just giving a triggering pulse to the main thyristor. I am giving the triggering pulse to the main thyristor. So now what will happen when you give the triggering pulse to the main thyristor? So the main thyristor, you can see this side plus is connected and second side minus is there. That means this is already forward biased. So as this is forward biased, then what will happen? It will start acting as a closed switch. When it acts as a closed switch, then what will happen? Your main supply that will start supplying the current to your load through your main thyristor. Through L2, it will supply to your load. Through L2, it will supply to your load. In this manner, the current will pass. That means there will be basically two currents that are passing. One current is supplied from the main supply to your load, and the second current will be, because when this main thyristor is turned on, auxiliary thyristor is not fired, so it is off. So this capacitor, you can see this plus terminal is connected like this through the inductor to the diode. So diode, this side is plus, this side is minus, it is connected to negative plate. So that's why diode D1 is forward biased. So because of this, the current will start circulating within this loop also. That means one more current will pass. That current I can take as IC. The same thing I have represented here. One current is IC because this diode is now acting as a short circuit. So the current will start passing through this diode. So let me just erase it so that this will be completely clear. So this diode, now what is happening? This diode will start conducting. So basically there are two currents that are passing. One current is the current that is due to the capacitor, that means capacitor is discharging. Another current is the load current. So we can tell that the total current that is passing through your main thyristor, that will be equal to your load current that I am taking as I0 plus the current that is passing through this capacitor. So here you can see this capacitor and this inductor L1. Similarly, one current is passing through the load, that because of this current passing through this inductor, because inductor opposes the change, so that's why one voltage will be there across this, which is given by plus this side minus this side. So both these coils are mutually coupled, so that's why automatically EMF is induced in L1, this side plus and this side minus. So now if you see the capacitor, this side is plus minus, again this inductor also this side plus minus due to current passing in L2. So that's why, because more voltage is there in this loop, so that's why the current will be very high, or the capacitor will discharge at a faster rate. That means using an auto transformer, this L2 current passing through L2 is helping in speeding of the process of charging or discharging of the capacitor. That means current passing through the capacitor. So I think up to here it is clear to you. So now let us see the waveform one by one. So then we will proceed further. So this is my main thyristor. Main thyristor, what happens at time t is equal to 0, we have turned on. So voltage across main thyristor will be 0. So now coming to current passing through the main thyristor, it is having two currents. One current is I0, let us assume I0 is constant, this is the value, plus the current passing in the capacitor. So we have seen in the tank circuit in our last to last lecture, you can refer to that lecture, tank circuit, how the tank circuit works. That means when you are connecting inductor and capacitor in series, how they will work as a tank circuit, that I have explained there. So there we have seen the waveform will be sinusoidal waveform. That means current will reach some peak and then decrease. So this current, this upper part is due to the capacitor current. Same thing I have mentioned here, you can see the capacitor current is increased, reaches some peak value, then it will decrease. So when the capacitor current reaches the peak value, then the voltage across capacitor, because capacitor is circulating through this one, slowly the voltage will start discharging in the capacitor. Slowly the voltage across capacitor will reach 0 at some time in between. So even though the current voltage across the capacitor is 0, but still the current will not become equal to 0 because of the tank circuit, because inductor will not allow the change in the current. So slowly now what happens, whatever energy is stored in this inductor L1, so that will start supplying the energy to the capacitor so that it will start charging in the opposite direction. So slowly as this is dissipating its energy, the current will goes on decreasing. So how this is happening, what is the equation, these things I have discussed in tank circuit. If anyone want this in detail, you can please refer to the tank circuit lecture in power electronics playlist. Okay, so I am proceeding further. So slowly the capacitor will start to the maximum value. So until it reaches the supply voltage, it will go on continuing the charging. Okay, so finally it will be charged to a voltage. Even it may be charged a little more than the supply voltage also, because whatever current is passing in the L2 that is inducing one voltage, that voltage will continuously supply the energy to L1. So that's why the capacitor will continue to charge. So it will charge even more than the supply voltage. So clear? So that means the IM, the current passing in the main thyristor, is sum of the load current plus IC. So IC is rising, then decreasing, and finally up to time T1, that IC will be equal to 0 because capacitor is fully charged. So then the current passing through main thyristor will be load current only. This IC will become equal to 0, or otherwise the diode will stop conducting after the time T1. Now coming to the auxiliary thyristor, you can see here auxiliary thyristor, how the plates are connected. So you can see this side plate, lower plate is connected to one side, left side of the auxiliary thyristor, top plate is connected to another side. So I have taken the reference voltage for this capacitor as bottom side I am taking as a reference, that means positive with respect to top. That means voltage across auxiliary thyristor will be same as the voltage across the capacitor. That's why at this particular time when you are triggering the main thyristor, the voltage across auxiliary thyristor will be equal to VC. As VC is negative here, you can see. So same voltage will be there across auxiliary thyristor. It will follow the capacitor voltage only. Same thing. It will reach up to the supply voltage. You can see it has reached up to supply voltage. So now across your auxiliary thyristor, the voltage is positive. That means it is now forward biased, and whenever you trigger the pulse, it is ready to turn on. So that thing you have to remember. I hope VM is clear to you, IM, VA, and what is the current passing in auxiliary thyristor, because auxiliary thyristor is off, that's why the current is 0. Similarly, voltage across capacitor and what is the value of IC. Now coming to the load voltage, what is the voltage that is across your load? Voltage across your load, initially it will be 0 until it is triggering pulse, because all are open circuit initially. So now whenever the triggering pulse is activated, now what happens, whatever is your supply voltage is there, that supply voltage you can see this is passing through L2 to your load. It is passing through L2 to to your load. So that's why your output voltage, if you apply the KVL, you can write it as Vs minus 2 plus I am going. Then this is VL2. VL2 you can see I am going from plus 2 minus, so I am writing minus VL2, and V0 I am going from plus 2 minus, so minus V0 is equal to 0, or otherwise I can write V0 is equal to Vs minus VL2. That means it will go to a value nearly equal to Vs, because VL2 will have a very small value. So now due to the coupling between the L2 and L1, so the value of this VL2, because there is a coupling between L2 and L1, because here you can see that IC is passing between the time T1 to T2. This IC is here. So this IC is passing through L1, and L1, because as the current is passing through L1, it is mutually coupled to L2. So along with the normal voltage, one extra voltage is induced due to current passing in L1. So that means that voltage is adding to this one, or otherwise we can tell that as V0 is equal to Vs minus VL2. So one extra voltage is there, that is decreasing our output voltage. And how, which is, it is happening due to current passing in L1. Or what is the current passing in L1? It is nothing but equal to IC. That means you can see here this value, when the current IC is rising, the output voltage is decreasing gradually. It is following the same sinusoidal pattern. So by the time the IC reaches 0, so that voltage induced due to this L1 is 0 in L2. So that's why your output will get stabilized. After that it becomes the steady state. Getting it? How this waveform came, it is clear. This is decreasing due to because L1 and L2 are coupled. So that's why, because this voltage will add to this voltage that is actually induced in L2. So until this current IC is passing. When IC is equal to 0, only drop will be due across the L2 only. So that's why there is a dip, because it is following the IC. As IC is decreasing, again it will come back to normal value. Up to here it is clear to you? Okay, now let us proceed going to mode number 2. That means I am taking at time t is equal to T1 to T is equal to T2. So by the time T is equal to T1, I told you the capacitor is fully charged. So which direction it is charged? Bottom side plus and top plate is minus. Bottom side is plus and top side is minus. So if you see the VC here, VC I have represented positive because I am taking my bottom side point as the reference positive for making the waveform. Okay, so that I can take that the whatever is the voltage VC, same thing will come across TA when it is turned off. Okay, so now what I am doing, so I am just now turning on the auxiliary thyristor. I will give a pulse and turn on the auxiliary thyristor. Okay, so now when you turn on the auxiliary thyristor, now what will happen? This entire auxiliary thyristor, because this plus terminal of this capacitor is now connected to your main thyristor. This is your main thyristor terminals. This is my main thyristor. This is my main thyristor terminals. So then it is going to turn off. So before going to this, let us see the steady state part. That means before firing the TA, what will be the condition? So now up to the T1, capacitor is fully charged. As the capacitor is fully charged, so that's why the diode is reverse bias, or the diode will stop conducting because current is 0. So now only one current will pass through your main thyristor. That current is equal to I0. That I0 will pass like this, pass through L2. It will pass through your load and return back. So we can tell that Im is equal to I0. Then voltage across main thyristor is 0, and the value of the Vc is reversed because the direction of the Vc is previously plus and minus is there. So now the Vc is reversed. It become opposite polarity. You can see here Vc, initially it is opposite, now it become reverse here. Same thing I am mentioning here. And the TA, because you can see this side is connected to plus of the capacitor, this side to minus. That means we can tell that this TA is, because this plus is connected here. So that means the TA is forward bias. It is ready to fire now. And output voltage, because under steady state condition, because inductor, what will happen under steady state condition? It will not oppose a change in the current. That means voltage drop across inductor will be 0. So entire voltage will appear across your load. So V0 will be equal to Vs. So this is just under steady state condition only. So now let us see what will happen when you turn on the auxiliary thyristor. So I am applying a trigger pulse to the auxiliary thyristor. When trigger pulse is applied to the auxiliary thyristor, this is my main thyristor. So what will happen? This capacitor, this positive will pass through this one and apply across this main thyristor. Negative terminal is here. So this main thyristor, my reference is plus this side minus this side. So we are applying the reverse voltage. That means we are reverse biasing my main thyristor. That means I am applying a reverse voltage to my main thyristor. So because of the voltage commutation or class D commutation, the main thyristor will be turned off. That means the main thyristor will be turned off. So the equivalent circuit will become like this. Main thyristor is turned off. So now what will the way the current can pass? Now auxiliary thyristor is on. So that's why from your supply, the current will pass through your capacitor, then it will pass through L2, and from there it will pass through your load and return back. So this freewheeling diode is actually off here in this condition. So current will pass through your load in this manner. Getting it? So this is from time T3 to T2 to T3. So T2 to T3, how my current is passing. So now what happening, that to analyze that, let us see when this is connected like this. So you can see the voltage across your load. This is the load. I am applying the KVL. If you apply the KVL, you can see this is Vs. I am going like this. This is Vs. And Vc. Vc is also in same polarity, same direction as Vs. So Vs plus Vc, that is minus VL2, that is applying across your load. Same thing I have mentioned, V0 is equal to Vs plus Vc minus VL2. That means this value will be many times greater, nearly equal to 2 times of Vs. As the voltage is very high, so the current passing through the load will be that voltage applied across the load divided by the impedance. So that value will be very high. So that's why current will suddenly surge to a large value. You can see the current applied by the capacitor is surged to a large value. Here the current direction is opposite to the reference direction. That's why I have taken in negative. So now what will happen? Slowly the capacitor will start, because the current is passing in this manner, the capacitor will start charging in an opposite direction, or otherwise the current through the capacitor will start decreasing slowly. The current through the capacitor will start decreasing slowly. But initially there will be a surge. Getting it? So now as the value of the Vc is decreasing, then what will happen? As the value of Vc is decreasing, because we know V0 is equal to Vs plus Vc minus VL2 from here. So that means as Vc is decreasing, so output voltage will also, because it is Vs plus Vc, remember here. So that's why V0 will also decrease. And finally, the I0 also will continue to decrease. So finally, by the time we reach T3, the value of the capacitor, because capacitor is now charging in opposite direction, the voltage across capacitor will reach 0. So after that, what will happen? The capacitor will continue to charge in the opposite direction, because here also there is an inductor in the circuit. You can see the capacitor is there, then inductor is there. Inductor does not allow the sudden change, so that's why it will continue to charge. So to understand this, let us proceed to this one. So T2 to T3. So now T2 to T3, because main thyristor is turned off, so voltage across this will be negative value, that is maximum value. That means the maximum value, what is the value? That value is nothing but equal to voltage across capacitor. As the capacitor is discharging slowly, you can see the voltage across main thyristor also decreased. Finally, up to T3, it will reach the value 0. So now coming to the main thyristor current, main thyristor is turned off, so current through it is 0. Now coming to the auxiliary thyristor, when it is turned on at T3, so that's why what will happen? The voltage across auxiliary thyristor is 0. Now coming to the auxiliary thyristor current, you can see whatever current is supplied to your load, that current is passing through Vs, through the capacitor, through auxiliary thyristor, L2 and load. That means auxiliary thyristor current will be same as the current that is passing in the capacitor or the load. So same thing I am representing, because the direction is same as the reference direction of the IA. So that's why the current waveform is coming like this. It will start slowly decreasing. It will continue until T4. Until T4, when the voltage across your capacitor reaches the very high value. That means in the opposite direction, greater than your supply voltage. So up to that time, the current will goes on decaying. Finally, it will reach 0. Okay. So now coming to the voltage across capacitor. So same thing is there. It will go on decaying and start recharging in the, or charging in the opposite direction. So same thing is the case. Capacitor current will goes on decaying. And now coming to the output voltage. Output voltage, when this is turned on, I told you the total voltage will be Vs plus Vc minus VL2. So it will be a very huge value, and slowly it will go on decaying. Up to T3, the value of the capacitor current voltage will be equal to nearly 0. That means your load voltage will be nearly equal to your supply voltage. It will be little less than the supply voltage by that time. I think this part is clear to you. So as the capacitor continues to discharge, so what will happen? So the value of output voltage also will goes on decaying. This is what I want to tell. So now going to the mode number 4. Mode number 4, I am taking from T3 to T4. From T3 to T4, the circuit will be like this. The current is again passing through your capacitor. Then it will passing through your inductor, through your load and returning back. So now what will happen? From T3 to T4, your capacitor voltage already reached 0. So it will start charging in the opposite direction now. So it will start charging in the opposite direction, because the current is passing like this. So what will happen? It will start charging in the opposite direction. So this side will charge to plus, this side will charge to minus. So slowly it will go on charging. But this polarity direction is opposite to our reference polarity direction. That's why I have represented here T3 to T4. From 0, the voltage will goes on decaying. That means the capacitor will goes on charging. So here what happens, as this inductor will oppose the change in the current, because as the current is decreasing, inductor don't want your current to decrease. So what will happen? It want to increase the current. How to increase the current? It will reverse its polarity, because it is a property of the inductor. It will oppose the change in the current. So that's why polarity will be reversed such that it will aid in passing the current, more current through your load. That's why it will become minus plus, or otherwise we can tell that this VL2 will add to Vs in supplying the process. So this will speed up the charging process of your capacitor. So because this VL2 is adding to Vs, that means your capacitor will come to a steady state position when the capacitor voltage is equal to Vs plus VL2, because that much use value it will reach. So that's why the capacitor will go on charging and it will go up to 2 times of Vs. So that thing you have to remember it. Okay. So once it gets charged greater than the Vs, so after that case, when IC reaches the current 0, so by that time what will happen? Because IC is nothing but equal to auxiliary thyristor current. So when the current reaches 0 through the auxiliary thyristor, what will happen to your auxiliary thyristor? So I am just representing here. Through your auxiliary thyristor, if IA is equal to 0, then it will turn off. So same thing I have represented here. T3 to T4, the auxiliary thyristor current is decreased. Once it reaches 0, this auxiliary thyristor is turned off. Once the auxiliary thyristor is turned off, so voltage across that, because this auxiliary thyristor is turned off, so then voltage across that will change. What will be the value? We are going to see. So now coming to the capacitor voltage will goes on decreasing. It will cross even the Vs at this point, and it will go on even increasing beyond that. So finally the capacitor current reaches 0 by this time. So by the time this capacitor current is 0, the voltage across capacitor is same as the voltage across auxiliary thyristor. So you can see that value is the negative value here. So that's why this much negative value is coming here. Okay. So how this auxiliary thyristor voltage is coming at T4? It is coming due to this reason. So now the moment the voltage across the capacitor has crossed your supply voltage, so then if you calculate the output voltage or voltage across your load, that will be equal to Vs minus Vc minus VL2. By the time the current reaches 0 or near 0, this value I can negligibly small or neglect it, or otherwise we can tell that V0 is Vs minus Vc. As Vc is higher than Vs, so what will happen? The output voltage becomes negative, because after this point, because your value of the capacitor voltage is increasing beyond your supply voltage. So that's why, so whatever the voltage is coming across your load, that will be negative. Whenever this voltage is negative, what is the meaning of this? This lower side plate is positive with respect to top side plate. As this is positive with respect to top side plate, what will happen? This freewheeling diode will be forward biased. So what will happen now? The current will start circulating through the auxiliary thyristor. That means your load will continue to carry the same current I0 through your auxiliary thyristor, because auxiliary thyristor will start conducting. So by this point, if you see, by this point, the current, the auxiliary thyristor current will be this much. You can see this much current is there. This will be nearly equal to I0. After this, your diode will start conducting, freewheeling diode. So current will start circulating through the freewheeling diode. So this auxiliary thyristor will fall, whatever current is passing through auxiliary thyristor, that can pass freely through the freewheeling diode. Getting it? So finally, the capacitor current will reach 0 at some point. So once the capacitor current reaches 0, then what will happen? That we are going to see in the next node. So now the value of the output voltage Vs minus Vc, that is negative. So freewheeling diode is forward biased, and hence it will start conducting. Okay. So now the auxiliary thyristor will turn off at T is equal to T4. This one also we have seen. So let us see what will be the case from T4 to T5. That means I am taking from T4 to T5. So at the T4, what will happen? The auxiliary thyristor is turned off, main thyristor is turned off. And we know the voltage across the capacitor, top side is plus, bottom side is minus. This voltage is greater than your supply voltage. So now freewheeling diode is already conducting. So it is a closed path. So now you can shake the loop. This Vc is greater than Vs. So it will start discharging the current through the Vs. It will pass through the freewheeling diode through L to L1, and it will go to Vc. That means the capacitor will start discharging now. So capacitor will start discharging. So that's why as the capacitor is starting discharging, the voltage across capacitor is decreasing. As it is decreasing, voltage across the auxiliary thyristor will goes on decaying. You can see that is going on decaying, and finally when the capacitor decreases very less value, it will reach the positive side. So same thing is the case. I am going for the VC. So VC, you can see the VC is going on decreasing from there. So again this one, because in this case also it is passing through a inductor capacitor combination, you can see here. Here there is a capacitor, here there is inductor. Again it is nothing but a tank circuit. That means the current will rise to some peak value, then decay. The same thing I have represented here. It reaches some maximum value, then decay. And finally, once the current reaches 0, that means the capacitor current is 0. When the capacitor current is 0, that means the voltage of the capacitor is nearly equal to or less than your supply voltage. Then your diode D1 gets reverse biased. It will also be open circuited. That means after time T5, diode D1 is open circuited, auxiliary thyristor is also open circuited, these are also open circuited. I am just repeating the process once again. The moment when the capacitor voltage crosses equal to supply voltage while it is charging through your auxiliary thyristor, then the moment it is equal to this supply voltage, that means that what will happen, your load voltage will become negative. As the load voltage become negative, the freewheeling diode will be forward biased. So I0 will start circulating in this loop. I0 will start circulating in this loop. So as the freewheeling diode is now conducting, so how the current will pass? It will pass from your capacitor through your auxiliary thyristor. It will pass through freewheeling diode through your Vs. Getting it? So by the time the current reaches 0, in this, then the auxiliary thyristor current is less than the holding current. When the current is less than the holding current, the auxiliary thyristor will be turned off. So now when this is turned off, by the time the voltage across capacitor is greater than your supply voltage. As it is greater than the supply voltage and freewheeling diode is conducting now, so it has a path to discharge through your supply voltage, freewheeling diode, L2, L1 and C. So it will start discharging. It will discharge until it reaches the voltage nearly equal to Vs. Once it reaches Vs, then D will stop conducting. So it will be open circuited. This is what will happen from T4 to T5. Okay. So now coming from T5 to T6, after T5 to T6, it will be the stable condition because it will be like this. Tm is open circuited, TA is open circuited, D is open circuited. Your load will continue to circulate the current I0 through your freewheeling diode because the value of V0 is negative. Or we can tell that nearly 0, little bit negative, because whatever voltage drop across the diode, that will be the nothing but a voltage across your load. Okay, same thing is the waveforms. I hope that all these basic concept is completely clear to how the different modes of operation are there and how it is operating. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you. Thank you very much.